Hello and welcome to today's class. Today we go over the basics of econometrics. Many times when working with statistics, we have to count. We can count the number of possible outcomes of an event that affects a business decision. Counting may involve ordered arrangement, known as permutation, or selection of things. That is combination. When combining objects, we are not interested in the order they occur. So, if I have a selection of 3 objects, A, B, C, then the order does not matter. So, ABC will be the same as BAC, and it is the same as CBA. But for permutation, which is the ordered arrangement of objects, order is important. Suppose ABC represents a combination lock. Then BAC would not open the lock. Therefore, the order is important. We can then see that ABC will be different from BAC, and it will be different from CBA. With permutation, there are instances where we are dealing with identical objects. For example, the combination lock could be A repeated 3 times. In that case, we have permutation with repetition. If we have n different objects to arrange, taking R at a time, with repetition allowed, this means we can pick the same object from the n R times. Then the number of ways that we can arrange the objects taking R at a time is given by n raised to power R. Consider, for example, where we have a coin which we toss 10 times. What is the total number of possible outcomes? For each toss, we have 2 possible outcomes, head or tail, and you can see them here. This is either head or tail in each toss up to the last one. Now, for each toss, we can get the same outcome. That means that we can get the same outcome in the first toss, second toss, up to the 10th toss. That is, we can have a head in the first toss, a head in the second toss, a head in the third toss, a head in the 4th toss, and so on, up to 10. So which means then we are repeating, each outcome has a possibility of being repeated 10 times. So thus, the total number of possible outcomes will be determined by taking n to be equal to 2 and r to be equal to 10. And so the total number of possible outcomes will be equal to 2 raised to power 10, which is equal to 1024. If repetition is not allowed, then we have to use a different way of counting. In that case, we use the factorial. The factorial of a number n is the product of all possible positive whole numbers less or equal to n, which is read as n factorial, n with an exclamation mark. Now, by definition, 0 factorial is equal to 1. The number of ways of arranging r distinct objects with no repetition drawn from a set of n distinct objects is given by n permutation r. Now, you have to be careful with the denominator there. N minus r factorial is actually not equal to n factorial minus r factorial, which means that the factorial operator is not distributive. Where order of arrangement is not important, then we use combination. The number of ways of selecting r objects from a set of n objects where order is not taken into account is given by n combination r. The latter notation here is also used to symbolize n combination r. Actually, in most econometrics and statistics books, this is the symbol you will find commonly being used. It is not a matrix when it is used thus. It means n combination r. Let's consider an example. A fast food cafe wants to hire 2 employees, one at the counter and the other at the drive-through window. Kamau, Atieno, Rotich, Kanze, Nanok have each applied for both positions. In how many ways can the 2 positions be filled, assuming all are qualified and can fill only one position? From the above example, we note that our problem is one that requires that we select 2 people from a group of 5 and assign each to a counter. Now, each counter can only be filled by one person, and order matters. For instance, having Kamau at the counter and Atieno at the drive-through is different from having Atieno at the counter and Kamau at the drive-through. Since only one person can fill one position. Since order is important, we have to use permutation. Alternatively, we can just use a table like this one and list all the possible arrangements. But you can think of a larger matrix where you have got 100 people who have applied and you're only selecting 2. So permutation would be a better option. So if we are using permutation, then the number of applicants is going to be equal to 5, which gives us n, and the number of positions to be filled is going to be equal to the number of arrangements we are making, and that is 2. So r is 2, n is 5. So the number of ways of filling these 2 positions is going to be given by 5 permutation 2, which when we use a calculator will give us 5 over 5 minus 3 factorial. And cancelling out this, we get the answer is 20, which is the same as what we got when we used the table. Let us consider another example. In an election, there are 3 positions to be filled, and there are 7 contestants, A, B, C, D, E, F, G. In how many ways can the electorate fill these positions? From this example, the interest is to have 3 people fill the three positions in any order. It does not matter who is elected first. Having A elected first, B second, C third is the same choice as having B elected first, A second, and C third. This is different from a case where the people would be elected to defined positions, e.g., chair, treasurer, secretary. For in that case, order would be important, since the position of a chair is different from that of a treasurer or secretary. But in this example, positions are undefined. All we care is that they are filled in whichever order. Our problem is then one of combination. How can we select 3 people from a group of 7? So we have, using combination, the number of people in the group gives us n, which is 7. And we wish to select 3 people, so r is equal to 3. The number of ways of filling these positions is 7 combination 3, which we use a calculator and we find that it is going to give us 35 possible ways. Let's now look at the logarithm function. The logarithm function is one that has common use in econometric modeling, especially when transforming data to reduce variation. If y is a logarithm function of x, then we write log ax. A is known as the base of the logarithm. We have 2 commonly used bases: base 10, known as the common logarithm, written as log base 10x, and base e, where e is an irrational number. An irrational number is a number that cannot be expressed as a fraction. The logarithm to base e is known as the natural logarithm, written as log ex, but most commonly written as ln x, that is lnx. This one is pronounced as ln x. To be able to work with logarithms, it is important we have knowledge of the rules of logarithms. Let's go over a few of them. If y is a natural log of x, then x is written as an exponential function of y. And if we want to get the logarithm of a product, then the logarithm of a product AB is simply equal to the sum of the logarithms. The logarithm of a quotient is simply equal to the difference between the quotients. The logarithm of a number a raised to power n is simply equal to n times the logarithm of a. The natural logarithm of e, where e is equal to 2.71828, is equal to 1. And the logarithm of 1 to any base is equal to 0. So that is a brief overview of some basics of mathematics that we apply and we will find useful in econometric modeling. Thank you. Hello and welcome to today's class. Today we go over the basics of econometrics.